This enables the tuning of practically all SQL statements that would be of interest to a user. SQL statements from these input sources are typically first loaded in a new object called SQL tuning set, which is then submitted as input to the advisor. A SQL tuning set (STS) is a new database object used for capturing SQL workload information. It includes one or more SQL statement associated execution context, such as user schema, list of bind values, etc. Associated basic execution statistics, such as elapsed time, CPU time, etc. SQL tuning sets provide the basic framework for capturing, managing, and tuning of SQL workloads. They allow selective on-demand tuning of system-generated and custom user-defined workloads and greatly simplify the task of tuning multiple SQL statements. With SQL tuning sets, users can capture any SQL statements of interest and store them in an STS for future tuning. They no longer need to manually build and maintain SQL scripts for tuning purposes. Furthermore, information pertaining to execution context and statistics that is captured in an STS allows for more superior and efficient tuning than would be possible for any custom SQL script. SQL Access Advisor. The design of the database schema can have a big impact on the overall application performance. SQL Access Advisor provides comprehensive advice on how to optimize schema design in order to maximize application performance. SQL Access and SQL Tuning Advisors together provide a complete solution for tuning database applications. These two advisors automate all manual tuning techniques currently practiced and form the core of Oracle's automatic SQL tuning solution. The SQL Access Advisor accepts input from all possible sources of interest, such as the cursor cache, the automatic workload repository, AWR, any user-defined workload, and will even generate a hypothetical workload if a schema contains dimensions or primary foreign key relationships. It comprehensively analyzes the entire workload and provides recommendations to create new partitions or indexes if required, drop any unused indexes, create new materialized views and materialized view logs. Determining the optimal partitioning or indexing strategy for a particular workload is a complicated process that requires expertise and time. SQL Access Advisor considers the cost of insert, update, delete operations in addition to the queries on the workload and make appropriate recommendations accompanied by a quantifiable measure of expected performance gain as well as scripts needed to implement the recommendations. SQL Access Advisor Recommendations page. Then recommendations are ordered by the workload improvement factor. User can select one or all of the recommendations and implement them by simply clicking the Implement button. The SQL Access Advisor takes the mystery out of access structure design process. It tells the user exactly what the type of indexes, partitions, and materialized views are required to maximize application performance. By automating this very critical function, SQL Access Advisor obviates the need for the error-prone, lengthy, and expensive manual tuning process. It is fast, precise, easy to use, and together with the SQL Tuning Advisor, offers the most accurate and co-effective solution for application performance tuning. Object Reorganization Wizard. Oracle Tuning Pack 11G also provides the ability to reorganize objects, managing the space usage of your table spaces efficiently by removing wasted space is not only a good space management practice, but it also enhances performance by reducing unnecessary disk I/O's. Reorganization is used for rebuilding indexes and tables that are fragmented, relocating objects to another table space, recreating objects with optimal storage attributes. Oracle Tuning Pack 11G provides a wizard that can perform reorganization at schema and table space levels, and gives the option for both online and offline reorganization. The wizard also provides an impact analysis report as well as a review script that contains the exact operations that will be performed. This helps users to precisely understand the application of the operation before implementing it. It is shown in this figure.